Okay, let's just discuss with performance analysis of algorithm. So how you can just define the performance of an algorithm. Uh, like there are two ways while defining a performance. You can define a performance with respect to space or with respect to time. So usually we call it as a space complexity or time complexity, and it defines like how efficient and fast your algorithm in executing with respect to time, that will fall under time complexity, and how efficiently it utilizes the space or memory space which is available to it, then it will fall under the space complexity. So you can just see that the space complexity of algorithm is amount of memory space required by an algorithm during the course of execution, called as space complexity. So now what are the different memory spaces are required for the algorithm? One could be your instruction space, another is data space, and then your environment, execution environment. So instruction space, like whatever program you are writing, any language you can take, each language will have some instructions or command, and whatever space or whatever memory that your code is required, that is the instruction space. Data space, again, what are the different variables you are using? You have some are the, let's say, kind of list or arrays you are using, which will be updated at each iteration. So that is again a variable space that initially you might have defined that empty array, and then it is increasing. So that size of array or required memory will go on changing. So that is your data space, like what are the variables we are using in the program and what kind of amount of memory they consume. That will fall under data space. And again, like while executing, you will use some environments to store the information, or environment information you stores at some places whenever you need to resume that suspended space. That is our environment complexity, like that will fall under the space complexity consumed by the environment. Now time complexity, with respect to time complexity, we call the amount of time, total amount of time required by an algorithm to complete its execution, that is a time complexity. So in this video, let's take some examples of space complexity and discuss. So space complexity we can denote with S of P, and it could be a C plus SP of I. So you can see that I stands for, here we can just say that I is our instance characteristics. I is instance characteristics. C is a constant space which is needed. Okay, so now you can just see that what are the different spaces here. That space, fixed space requirement C, and then variable space is I, SP of I, and SP of I is depending on the particular instance, like what is the instance of that particular code or algorithm, we can say. Now you can see fixed space, in the under the fixed space you will have instruction space, as we discussed what is instruction space, and a space for simple variables, like there are some variables which you will define as one constant variable, or there are some variable which will consume a fixed space. Those variables will fall under fixed space requirement. Now about variable space, as I have given the example before also, that you have defined one array or list, and at each iteration its size is changing, so that is your variable space, and it depends like how the based on the conditions that value will be depending. So that is why that space is variable. So it is, let's say here, number, size, values of inputs and outputs associated with I. Then even if we have you remember we have discussed the recursion. Under the recursion we have seen that while executing the recursion, it will execute base case first, but it will start from the top down approach. So the main like the topmost part it will execute, and then everything it will push on the stack unless and until it gets some answer, and then it will just go on popping on the stack, and it will get the final answer. Then there are some of the formal parameters we will have, and some of the return addresses as well. So this is like variable space requirement. So now let's take one example. You can see that like this is a simple code snippet from Python. forget about it. Let's say it is just one function written, and that function is written for one algorithm. Like algorithm 1 we have defined, and it has some variables a, b and c inside it. So now what should be the space required for the for this algorithm? So what it does is it's just returning one simple equation which consists of these three variables a, b and c. So as a part of this code we need fixed space, because a, b, c are some variables. So whatever space required for a, space required for b and space required for c. So let's say we will need 1 unit of space for a, 1 unit of space for b and 1 unit of space for 3. So total space, like I could say that S of p for this case is 3 for variable a, variable b and variable c, because anyway the operation which we are performing is a plus b plus b into c plus a plus b plus minus c, and that thing is divided by again a plus b. This is one term, and then one more term which is added as a 4 here. So what about this term? As I have written here also that 4 does not consume any memory. But why it is not consuming? Because see, we have directly used this number 4. It's not like we have defined some constant variable first and constant, and let's say variable d equal to 4, and then we have written a d here. Then it could be we could say that this d also requires some space because we have already defined one variable. But this 4 is already there into memory, so that's we don't need to declare this 4. We have not declared this 4, so we can assume that this 4 does not require any memory. So that is why your space complexity for this algorithm is 3. Let's study one more algorithm, and then we'll see one more about recursion as well. Okay, so say this is a list sum. This is one more function where it takes input as a list and one number n, and now what it has to do, it has to sum all those numbers, or you can just say that it is summing all the numbers in the list. So this n also is not needed in this code, but let's go ahead. Okay, so initially we have defined sum as a 0, so sum will consume one memory space unit. Then here list has a size n, will assume, so list will consume n unit because it has n elements, so space is n. And again sum is, as we have discussed here, there, but I also is one of the iterable. It also may need one this one unit of space. So now you can just see that at each iteration of the code, this 1, n as well as I, this like list, sum and I are being used, and that will be running every time. So that is when the amount of space, so two constant spaces are there, that is 1 and this sum variable and this I variable. So this one is for sum, this one is for I. So two are falling under fixed space and list is falling under the variable space. That's why I could say that variable is your list 1. So now the total space required is sum of these two, and what is the space taken by this n? So it is 2 plus n, or n plus 2 is your space complexity. So minimum of that, it could be like if some other thing happens, it could be like more. So the space complexity for this code, because we have a variable list here which will consume n plus 2, because two different variables are, one is for sum and one is for this variable I, that is iterable I which we are using.